All right, hello guys, and welcome. Today I have another interesting question, and it has a lot to do with the trigonometric identities. So the problem is basically saying that we have a bar. So we have some, let's say a triangular bar that happens to be about 2.5 meters, and it is fixed at the point 0, 0. So it starts at the origin. So if we were to say, let's say that this point over here is the origin. On the graph, it would be 0, 0. And then over here, then it would be 2.5 on the x-axis. And the y-axis would obviously be 0. So this point over here would be 2.5 and 0, like that. And then furthermore, it is saying that the bar starts rotating. So it starts going like this, up at t equals 0. The initial position of the bar is at the x-axis. So this is the starting position. Furthermore, it's giving us more information that the angular velocity, so omega, it's 0.23 seconds. Part A is asking us to calculate the x coordinate of the free end after the bar moves for 4.5 seconds. So it's basically asking, hey, what is the value of x after 4.5 seconds if the bar starts rotating at t equals, so at 0 seconds, with the velocity of 0.23. So before we start tackling the problem, let's look at it on a graph. So I am going to draw this over here, and let's say that this is our bar, and it happens to be, let's say, 2.5 meters long. That means that if it is 2.5 meters long, it lies at the 2.5 value of x and 0 value of y at this position. So when t equals 0, this starts rotating up, and I want you all to maybe pause the video and imagine what happens to the x value as the bar starts rotating upwards. So let's imagine if the bar was, say, at this position at some time z, for example. So what would happen to the x value? If you look from over here, the x value clearly decreases. It will become less than 2.5. So at t equals 0, the value of x was at its max. And as the time goes forward, at some point, the value of y will become max, which will be 2.5 as well over here. And then it will start going down again, and the y value will decrease, and the x value will start gaining again on the negative side. So next, let's have a look at sine and cosine. So here, the blue one is the sine wave, and notice that the sine wave is starting at 0, and it's going up, 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 and then it's hitting a peak, which is the amplitude. This is called the amplitude, the highest point of the wave, and then it starts collapsing again, down, 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 and then it starts having another amplitude, but at the negative side. So it starts having another amplitude down here, and then goes back up to 2 pi. So this is basically one full circle. So we could think about this as one full rotation. The point is that it starts at 0 value. So if we were to have a y, x graph coordinates, and we have a bar over here, so notice that our bar at t equals 0 is placed on the 0 and 2.5. So the value of x is 2.5, while the value of y is 0. So sine would be very appropriate in this situation, because look at that. Just like how we want it to behave, it starts the y value, given that this is y, of course, the y value starts at 0, just like our graph, and then starts going up, 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 up until it hits the max y value, which let's put over here is 2.5. So just like this, it's as it goes up, it will hit our max y value, while our x will become 0, but that can't be seen or in this graph because this graph is against time. So as time increases, this will go, the y value will start rising from x, and then it starts collapsing down again. So as it comes down again, the x starts gaining on y. So as it is in this position again, the x is at max while y is at 0. So that is this position at pi. And then again, it will go back to give y to hit the max amplitude at y, but on the opposite axis, and that would be on the graph over here at the opposite axis, so the negative side. So it will be another 2.5 right over here. Okay, so similarly, we can have a look at the cosine wave. So notice cosine wave, if we were to ignore this negative side, since our time is set to start from 0, so this will be 0, so we have to consider from this point. See, notice that the cosine starts from 2.5 amplitude. So if we were to refer back to our graph again, notice that this is 2.5, so our x is starting from 2.5. So max value, so cosine would be the more appropriate way if we were to look at this from xt graph point of view. So from at t equals 0, x has its max value, and then it starts going down as y starts gaining on it. So it will go down to 0. So this will be 0 for x, and then again x will be at its max, but on the negative side, which is down here, and it's over here, negative 2.5. So I hope you understood that. And so looking back at the question quickly, we can see that we have now successfully identified that 2.5 is our amplitude. I'll just write A for it. And furthermore, we have found out that the point of initiation is 0 seconds. And we also know that omega is 0.23. And we would like to know that after 4.5 seconds, where will x end up? So from the analysis that we did on these two types of wave, we concluded that cosine is the appropriate wave to use since we are trying to find the location of x at a certain point. So what we are saying is that if this is x against time, then as time goes forward, what happens to x? So for example, I'm going to say that, hey, this is 4.5 seconds. What is the value of x at this point? So as we follow the cosine curve, we can find the value of x. So that's the idea right now that we're going to go by. So the formula we would be wanting to use would be amplitude times cosine omega t plus phi. But notice that our point of origin was at 0, 0, so there was no shift angle. So phi is essentially non-existent over here, so phi can be ignored. And now we can actually plug in the values over here. So amplitude 2.5, cosine omega of 0.23 times 4.5. And right over here, we want to know, hey, what is the value of x at this time? So time is the variable that can change. These two are constants. Okay, I'm putting this into a calculator. We will get an answer of about 1.276, and it's asking for 2 decimal places, so 1.228. So what we are basically saying is, if we go over here to our graph, is that after 4.5 seconds, the value of x, so let's say, for example, this value over here, will be 1.276. And that makes a lot of sense, right? Because as it's rotating, the value of x is decreasing, and it had the angular velocity of 0.23 seconds, which is really small. So it was going quite slowly. So it makes total sense. So the second part is now switching. It's saying that, hey, when will the free end be at 0.83 meters on the y coordinates after t equals 0? So what this second part is asking is saying that, hey, if we have our bar again over here, the bar at t equals 0 starts rotating towards here. At what point after t equals 0 will the value of y, so let's say that if this is the peak value, 2.5, at what point will it be 0.83? So let's think about it. So when it comes a little bit up, maybe around over here, then the value of y will be 0.83. So what we will need to find now is the time. Now, since we are explicitly now talking about the y value, let's look at which sign is more appropriate to use. So cosine, we agreed that it starts at 2.5 amplitude, which was appropriate for x, because x started at 2.5, while at t equals 0, y starts at 0. So sine also starts at 0, which is very appropriate, and it goes up, 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 up. So as time goes by, y starts gaining, and our point of interest is somewhere over here, and this is the time where y is 0.83. Okay, so let's think about how to write the formula. Since we said that the amplitude equals 2.5, so we would need, we have an idea that we will need the general formula of a times sine omega t. And the same case again, phi can be actually ignored since it has no shift. So we do know a, which is 2.5, and we realize that it's a sine. It has a sine-like behavior, and we do know that the omega is a very slow 0.23 times. We don't know time now. Time is what we need to find, and we want to find the time when the y value is 0.83. Okay, so now it's just a quick algebra, nothing too difficult. So now we have a sine 0.23 times t equaling 0.83 divided by 2.5. So you should get somewhere about 0.332. Okay, and now we need to get rid of the sign. So we do that by taking the arc sign of the result. So if we take sine -1 of 0.332, that should give us 0.338. 0.23 times t equals 0.338, and t equals 0.338 divided by 0.23, which, let's put it in rainbow, gives us an answer of, that gives us about 1.47 seconds. And that is our B. And in case you didn't realize, 1.28 was the A value. So this is our X value. All right. Thank you guys for listening.